Hi, welcome to Office Hours, virtual office hours that is. This week, much of your problem set focuses on the topic of deriving equations of motion. So what I'd like to do is review the steps one goes through in that process and then show you an example. First, identify the number of degrees of freedom and the generalized coordinates that describe those. Second, along the way, identify any kinematic constraints linking those variables. Third, draw the free body diagrams, the external forces impinging on the rigid bodies. Next, apply Newton's laws, summing forces in the appropriate directions and summing torques about the center of mass. Then eliminate the unknown forces, such as normal forces and reaction forces. Incorporate the kinematic constraint, and finally you have your equation of motion. So watch this example. There's enough algebra in this problem that you might well want to slow down or stop the video from time to time to enable you to follow along with pencil and paper. A cylinder of mass m and radius r is rolling without slip on a horizontal surface. Two springs of spring constant K are attached to the topmost point of the cylinder. Derive the system's equation of motion in terms of theta. Non-slip rolling clearly imposes a kinematic constraint on translation and rotation. The free body diagram contains the force of gravity, the normal force, the friction force, and two spring forces of magnitude kx. Note that the friction force F is unknown, so its direction and magnitude are arbitrary. Summing forces in the x direction, we get the following. Summing torques about point G, we get the following. We isolate the unknown friction force and substitute it into the equation summing torques. Rearranging, we get this. Substituting in the kinematic constraint, we get the equation of motion in theta. All right. Next, I'd like to give you a clue about the problem on your homework that involves the falling stick. A key point to recognize in this problem is that because the rigid body is falling and sliding on a frictionless surface, there are no external forces on the rigid body in the horizontal direction. Consequently, the center of mass undergoes no horizontal motion. Wherever the center of mass was placed at the beginning of the problem, it falls straight down along a vertical line. So, good luck with this one. All right, so that's it for this week. See you next time.